All right, all right, all right. One more time, once more, I say apologies, guys, for for this delay, for this delay. So today's class is the beginning of the proper journey into DevOps. So from today, uh, you would start seeing some elements, all right? Major elements of DevOps, all right? Major elements of DevOps. And if you watched my video on how to become a DevOps engineer, I did share that video. I did share that video with us, all right? And like we mentioned in that video, DevOps is a methodology. It is a culture. DevOps is a methodology, all right? A culture, okay? A culture, all right? A culture. And in this DevOps methodology, there are categories of tools, right? There are categories of tools. And the first category, right, I call that version control. So under version control, we have tools. I wouldn't want to define it, but when we start properly into version control, I will define it. I just want to list those categories to remind us again, right, of what we are actually getting into. So in version control, we have things like SVN. SVN is an example of a version control. SVN is subversion, something like that. I will check, guys. Subversion, I will check. Now we have Git. We have GitHub. Okay, let me put them here like this. We have Git. We have GitHub. We have GitLab. We have Bitbucket. Bitbucket. All right. Great. Now, under same category, we have containerization. And in containerization, we have a tool called Docker. Okay. Now, containerization and orchestration. Let me put it like that. And orchestration. Okay. So we have Docker and Kubernetes. All right. We have Docker for containers. All right. Okay, let me do it properly. Let me separate these guys. Let me separate these guys so that let me separate these guys. So we have orchestration. So under orchestration, we have Kubernetes. Sorry. We have Docker Swarm. We have OpenShift. What else do we have? Yeah, these are the big guys. All right. Okay. Right. Now, after these, we have infrastructure as code. Infrastructure as code. So under infrastructure, we have things like Terraform. Okay. Terraform. We have ARM templates. And we have cloud formation. Now, Terraform is an open source. Terraform, though now Terraform is no longer open source because it has is now licensed. but let me just put it. Take note, it's no longer open source. So Terraform is no longer open source, but I'm just, right? Let me just put it like this, HashiCorp. So it's of HashiCorp because it's no longer open source. ARM template is from Azure. Then CloudFormation is native toward AWS. This guy is here. Is Cynthia here? Bam, bam, bam. Okay, she know the voila. All right. CloudFormation is native towards AWS. Then we also have this guy called Ansible. Ansible is not partially, all right? You can actually provision resources. You can actually categorize Ansible as an IAC, though Ansible was not designed for that purpose. But as technology evolves, modules were created. Ansible became an infrastructure as code. But originally, Ansible wasn't designed for infrastructure as code. It was Terraform, ARM templates, CloudFormation. These were tools that were designed primarily for what? For infrastructure as code. All right? So we are coming. Configuration management. This is where Ansible comes into the picture. Ansible is designed for what? As a configuration manager, right? Then we have CI/CD, which is continuous integration and continuous delivery. Now, there is another CD, all right? So naturally, it is CI/CD. Now, CI/CD/CD. Now, this other CD, all right, is, let me pipe it, continuous deployment. All right. So we are, I wouldn't want to, I'm just giving us the entire stack at a higher level. After this guy, we now have monitoring. You have to come down. Yeah. So under okay. This is the meaning. Sorry, there's a meaning. Then the tools are, we have Jenkins. Sorry, we have GitHub Actions. We have GitLab CI. We have TeamCity. We have Travis CI, something like that. Travis CI, etc. Monitoring, then plenty. Prometheus and Grafana. We have Datadog. We have Sysdig. We have New Relic. We have Nagios. We have Grafana Cloud. We have Stack. There are many guys. All right. There are so many. So these are the categories, right, of the DevOps methodology. Okay. Subversion, something. All right. So that being said, in today's class, we will be starting with what? Version control. All right. So version control in a layman definition, let me push this guy, push these guys to the bottom. All right. A version control is a system. A VC is a system that allows developers to continuously save their codes in repositories, their codes in repositories. All right. This is a very lame definition. Very lame definition. It's a system that allows developers to continuously save their codes in repositories. All right. Let's look at the proper definition from Google. Let's look at what is version control. A version control, also known as a source control, is a practice of tracking and managing changes to software code. All right. This is the standard definition. All right. It's a practice of tracking and managing changes to your software code. So version control system are softwares that help software teams manage changes to source code over time. All right. System that allows developers to continuously save their codes in repositories. Something close. Okay, but go with this definition, guys. Go with this definition. All right, great. Now that we've known what a version control is, all right, in this class, we will be talking about Git and GitHub. So Git is the default CLI. All right. It is the default source control tool for interacting with all version control tools. Let me put it properly. Git is a default CLI tool, a CLI utility for managing other version control system. I will explain. On Azure DevOps, all right, the version control system on Azure DevOps is called TVS something. Let's check. Azure DevOps version control is called TV something. Let me find TV. It's not there. TSVN. No. This is not the way, guy.
It's a TSVS.
TSVST. Okay, this is Visual Studio. TSVS. TSVS Azure. Azure DevOps. TSVS. Okay, what is TSV in Azure CLI? TFS is better. Git or okay. Getting
Sorry, TFVC. Pardon me.
F
VC.
Okay, now thank you. Yeah, yeah, yeah. Team Foundation. Thank you. Yeah. So for Azure DevOps, thank you very much. Thank you very much. Okay. So for Azure DevOps, we have the default. Let me not use this guy. Let me use this guy. Now, for Azure DevOps, the default Git is TFVC, which is Team Foundation version control. Now, for AWS DevOps, we have what we call code commits. Now, we now have GitHub. We have GitLab. We have Bitbucket. Now, what I'm trying to explain here is, in all of these kinds of version control, the tool, the utility that is common to all of these guys is Git. So I can use Git, same command though, everything we're going to learn today, nothing changes. Nothing changes. But the only thing that changes is just the environment. The environment is because it's Azure DevOps, because it is Azure AWS DevOps, because it is GitHub, it is because it is GitLab, or because it is Bitbucket. That is the only thing that changed. Else, every other thing, command line, remains the same. Everything like, where's that version control? Everything like git init, git add, git show, git commit, git branch, merge, log, it remains the same, guys. All right, it remains the same. So happy at the back of your head, Git is a default CLI utility for managing other version control systems. All right, other version control systems. Okay, great, great. So I think this is everything. So let me copy this guy. So without further ado, let us get started, guys. Let's get started. Let's get started. All right. So first thing first, I'm going to gain access to my virtual machine and I'm going to install Git. Very simple and straightforward. So here's my server, connect, SSH client, copy my key, come to my terminal. I want this yellow, please. Some more. New tab, that's man page. All right. Okay, sudo. Okay, let me just remain here. Great, great. Now I need to install what? Git. That is what we have. Install Git, right? So this is what I'll do. I'll say what? Yum install. I am using Yum. You know already why I'm using Yum. Because this is what? A Red Hat flavor. Amazon Linux too. So Yum install Git. Yeah. So this guy will be installing the parents package, which is what? Git. And these are the dependencies that comes along with Git. I'll say why. Yes. So Git has been installed. If I type Git, so these are Git commands: Git, Git reverse pack, Git shell, Git dash, dish upload, whatever, wherever. I have installed what? Git. So simple. The next thing now is I want to start playing with Git, all right? So I would need to create a directory. Let's create a directory. mkdir, let me call it works, all right? Works. I have a directory. So change into works. I have changed into works. If you check pwd, I am what? Inside of works. Now, if I check ls-a, there is no file in here. There's no file in here because this directory has not been initialized as a Git repository. Thank you. We've gotten a new word. Now, so that's before I talk about going into initializing the Git directory. Let me talk about something called repository. Repository, as you all know, is a word that is used to describe something in abundance. Repository of knowledge. That's bag of knowledge. Repositories of good deeds. Repositories of nails. Repositories of good people. Repository of images. Repositories of source code. Repositories of softwares. Repositories of packages. All right, that's abundance of packages. Okay, so now in the context of Git, or in the context of version control, the place where our source code is stored is known as repository. In the context of version control, the location where all of our software codes are saved is known as repository. Repository. It's known as repository. Now, in the context of version control, we have two kinds of repositories. We have a local repository and we have a remote repository. Guys, pay attention now. In the context of version control, we have two kinds of repositories. One is a local repository and the other is a remote repository. Local repository because it is local to my base machine, to my server. Now, this is it now. So the moment I initialize this directory, I can start creating local repositories. So this in my machine is a what? Is a local repository. But the moment I start interacting with external repositories, external repos, like GitHub, GitLab, Bitbucket, code commits, Azure repo, Azure repository, etc. These are termed as remote repositories. So it means that I want to be in my base machine, all right? And either after developing my code, I want to push this code to GitHub. I want to push the code to GitLab. I want to push the code to Azure repository. That is what we call remote repository. So we're going to see the serving of these two repositories, right? So for today, we are going to play back and forth with what local repository. Then if time permits, we are going to go into an introduction to remote repository. So we'll see how remote repositories are being done. All right, so let's get started, guys. So that was it. Now, in my course content, I need to initialize this guy as a local repository. Now, I'll come here. The command is simple and straightforward. All I need to do, I just need to say what git init. So git init is going to initialize this directory as a local repository. If I hit enter, look at what it's saying now. Using master as the name of the initial branch, this default branch name is subject to change. To configure the initial branch name to use in all of your new repositories, which will suppress this warning, call this command, git config global init the default branch, the branch name. All right. So to suppress this whole thing, they say we should always use this command. Names commonly chosen instead of master are main, trunk, and development. The just created branch can be renamed via this command. Branch name modify, the new name. Now, initialize empty Git repository on home, the EC2 user, the directory. Then it created a file called .git. Now, if I check in this location, that file, I'm going to see a .git, right? Now, let's look what's the content of the file. The content of the file is branches, config, description, head, hooks, info, object, reference. So let's check what's inside of branches. There's nothing because I have not made a commit to the branch, right? Great. So we shall see a lot of commands, okay? To see all commands, possible commands, just type git and press enter. So once you type git and press enter, you're going to see a lot of usable commands, all right? Let's go at the top. So you've seen me use git clone, all right? Git clone is when you clone a remote repository. You want to have a remote repository into your environment, all right? So let's just do that briefly. Let me create one more directory. Let me call it clone me. All right, I have a clone me. So change directory into what? Clone me, pwd. Now, I'll go to GitHub. Let me go to GitHub. Let me look for a file. Let me say sample HTML SSLs. This project, let me call it GitHub projects GitHub. Let's look for one project. Let's go there. Now let me look, take anyone, guys. All right. So now I need to do something. I need to clone this guy's code. I like this guy code, this code. I want to use this code. So this is what I will do. I'm going to go, I'll go to the version control. In this case, it is GitHub. So I'll be using GitHub, all right? It's the same concept, guys. It's the same concept with GitLab, with Bitbucket, with Azure DevOps, with Azure repos, with code commits. It is the same concept, guys. Nothing changes. All you need to do is just to use your head. Once you are exposed to Bitbucket, all right? If you open Bitbucket, similar thing, guys. All you need to do, the same concept. They have the same concept, code, issues, pull requests, actions, projects, same thing, all right? So once you open your repository, this is your repository. This is the name of your repository. Come to where you are, you see code. Once you see code, right, you see a section, clone. This is for cloning. Copy this URL. This URL is for HTTPS. This one is for SSH. This one is for GitHub CLI. There's a GitHub CLI, all right? All right, but we shall base our studies between HTTPS and SSH, all right? So for now, let's go with what? HTTPS. So click on HTTPS and click on copy. Copy. Now come to my terminal. I'll say what? Git clone. Git clone what? I'll paste the URL that I copied and I'll hit enter. So you can see I have downloaded this repository. So I have everything here now. So if I check the content of this repository now, I should see all those files. You can see I have app.js, app.js is here. I have images here, index.html, license, readme, style.css. So with git clone, it enables me to copy, to clone, all right, the source code from a GitHub repository into what? My base machine. So let's go back there now. Git. So we've seen git clone. We've also saw git init. Okay, great. Now let's get cracking. Let's go back to our set of commands. Now, as I am now, this is my local repository. Let me remove this guy. Clone me. All right. Here's my local repository. So I want to start creating my files. Right. So I'll say touch app.js. Assuming this is my app.js. Touch package.json. Touch test.js. Now I have these three files. These three files, they are outside of my repository. They are outside of my repository, in as much as this is my local repository. So this is a command I will use. I'll say git show. Sorry, I'll say git status. So git status is used to show your files it's used to show your untracked files. It means that files that you have not been added, that has not been added to the repository, to the tracking section. All right. So the status command, the GitHub command, the git status command is used to show those files that are in untracked section. Now, we have both tracking and untracked section. And I can see now, nothing added to commit, but untracked files are present. They now say what? Use git add to track the files. So far, these files cannot be tracked by the local repository. That's why you see the color. The color is red. All right. So now Git is now telling us that these files are not tracked. For you to track these files, use a git add to track them. Now it means that after creating your file, the next set of command you will use is git add. So git add, I will specify the file. I want to track app.js. I will hit enter. Now I want to check the status of my track files and the untracked files. I'll say git status. So you can see these files have been moved from the untracked section to a section that we call what? unstaged section. All right? To a stage section. So invariably, we could call on track as on stage and track as stage area. We call it stage area and track area. On track area and on stage area. So it's either language, right? This is on track files, on stage files. These are tracked files or staged files. All right. Now, these guys have been added. However, they've not been committed to your repository. They have not been committed to your repository. The third command you will type is git commit. Git commit, you use a -m flag. A -m flag is used to pass a commit message. A commit what? Message. Now, you give it a message. You call it a meaningful message, added app.json file. It has to be in quotes, and I will hit enter. I've committed, here's that section. I've committed this file. Now it says what? Master root. Added this file. Committer, EC2 user, blah, 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 blah. Your name and email address were configured automatically based on your username and hostname. Please check that they are accurate. You can suppress this message by setting them explicitly. Run the following command and follow the instructions in your editor to edit your configuration file. Git config global edit. After doing this, you may fix the identity used for this commit with git commit amend reset author. So one beautiful thing with Git is that even when you're making mistake, Git has the tendency to correct you. I don't know how they've done it, but the people who did this thing, all right, they've done a great job. There are n number of times I have forgotten my git command, but I'll just type one or two lines, one or two keywords. It will drop an error. Once it drops an error, it will give me a suggestion that, are you trying to do something like this? Immediately, I'll just see it. So we are going to see things like that. All right. So let's start off with this. So now in GitHub, what this guy is trying to explain is that by right, you are supposed to set your username and your email address before running any Git command. This is required so that Git will know who did what. Who did this commit? Who did the commit? So Git should be able to track who did this commit, who didn't do this commit. So by that, that's why Git requires that your name should be what? Should be configured. So we want to see that part now. So I'll copy this guy. I'll copy it and I'll paste it. I'll hit enter. So this is Git per user configuration. So user, let me come here now and let me put my name somewhere. Let me say Frank. Escape, save and quit. So he said, after running this command, run this command, copy and paste, enter. Added this file. Just save it, don't do anything, just save. Now, it's now giving me a more explicit, look at now, from this guy. Look at now. Your name and email address were configured automatically based on your blah, 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 blah. You can express this guy by setting them explicitly. So this is what I need to do now. So let's start with this guy. So I'll say what? Let me copy this guy. Copy. So I'll come here. My name is Frank. So I need to track, Git need to track me. So your username is user.name. So it will be user dot, oh no. User.name is Frank. That's how it should be. Git config global user.name is Frank. Enter. Now, user.email, you have to also give your email address. So I'll say frankiesinfotech@yahoo.com. Enter. All right. So, the reason for this now, I'll show us the reason for this. So that whenever I check for the log, the commit log, whenever I check for commit log, I'm going to see whosoever did, if there's anybody who did the commit. All right. So Git is going to show me who did the commit. And by so doing, it helps us to track what changes were made to our repository. All right. So there's a command called git log. So git log, if I do git log and hit enter, so git log is going to show me all the git commits. So you can see I have author, I have the commit ID, author, and date. Now the author is EC2 default user, which is this guy. That was before I did this global configuration. All right. Now I want to do another commit. And I'm going to check the log and show us. So I'll check my status. Git status. I still have these two guys. So I'll add one of them in now. I'll say what? Git add package.json. Enter. So if I do git status, so that file has moved from the on stage area towards the staging area. Okay. Now look at this command now. If I need to move this file back to the on stage area, I'll use this command git restore -- staged, then the file name. So this is what I'll do. Git restore -- stage, then the file name. The file name is package.json. So I have moved this guy from this green area back to this red area. So let's check git status. So you can see I have unstaged the file with this command git restore staged the file name. Guys, you have to practice this thing back to back. As a beginner, you have to practice back to back. Now, let's add it back. Git add the file name, package. Git status. I have it here now. Great. Now, I need to commit. You have to commit, guys. Git commit. Now, when I use this message flag, I'll pass my message. All right. I am suppressing something. I will show us that thing I'm suppressing. All right. I want to use this git commit without this message flag. So I'll say what? Git commit. Enter. So this command is going to open for me an editor. It's going to open this editor for me. Now in this editor, I'm going to type my git message. Now you see, please enter the commit message for your changes. Line starting with this will be ignored, and an empty message about the commit. So you must type something. All right. So I'll say added package.json file. Escape shift WQ. It did now tell me that one file was added, one file changed, 0 insertion, 0 deletion. Create mode is this. So if I check git status, it will tell me that on this branch, this is nothing added to commit, blah, 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 blah. Now let's check our git log. So if I say git log, you will see that the author is Frank and the email is this guy. So if I come back here now and I reconfigure that and I say git config dash global user dot name is Toby. Enter. Git config dash global user dot email is Toby at yahoo.com. Enter. Now, if I add a file, git status, git add, test, added, git commit, pass your message, added test.js file. Enter. That's been added. Now, if I check git log, my git log is going to show Toby. Toby is the guy that did that commit. Currently, it is Toby that is active. If I create another file, touch finance.txt, check the status. It's on track. If I add it, git add finance, git commit, message, please. Git message, added finance file, added, git status. My branch is clean. Now, all right? My branch is clean. Now, git log. You see that Toby added the finance file. So if you need to change the user, you have to do your configuration. Git config dash global user dot name is back to Frank. Enter. Git config dash global user dot email is Frankie's infotech at yahoo.com. Now, I touch a file, touch audit.csv, git add audit, git commit -m, added audit file. Now, git log. Go to the top, you see that Frank has added the audit file. So this is the play, guys. All right. So far, we've been, let's check history. So these are the commands I have been playing with. Let me wait. Let's copy them. Let's copy. Copy. Come over here. Paste. Oh, shit. Fuck you. Let me take them one by one. But just note, sharp. Just note. Know what they are. Git initialize, git clone, git add, git first, git status, git add, git commit, git log. Now configuration, git config dash global user dot name, git config dash global user dot email. I think that's all. All right. That's all. Great. Keep it somewhere here. All right. So all these guys are now in my what? Local repository. These guys, they are now resident on my local repository. Okay. So we've seen git add, git commit. All right. So let's now look at branching. Before we talk about branching, okay, let's talk about branching before we talk about branching strategies. So branch are like, one second, guys. So branch, remember the shape of a tree. All right. A tree has several branches. A tree has several branches. This guy you're seeing here that is holding these branches is called the trunk. Let's call it the trunk. Call this guy the trunk. Then these guys you're seeing, these are the branches. Branch, 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 branch. The same concept is applicable to version control system. So we have a concept called branch. Every code is organized into a bucket called branch. So let's take a look at what's the definition of Git branch. So in Git, a branch is a separate version of the main repository. Thank you. You could be asked in an interview, what is a branch? Please take that definition. It is the separate version. A branch in Git is a separate version of the main repository. The main repository here is called master. Let's check. To check that branch, I'll say git branch. There's a command called git branch. The main repository here is, sorry guys. Branch, master is a branch from the main repository. Now look at this guy now. The main repository is this guy, one-page website, HTML, CSS project. This guy you're seeing here is the organization name. Shaifa Afan is the organization name. This is a repository name. This repository has branches. The branch are the separate version from the main repository. A branch in Git is a separate version of the main repository. All right? That is it. Okay? Now, to talk about branch, we have a command called git branch. Git branch is going to display all the branches that you have. If you need to create a branch, let's create branches. How to create a branch? I'll say git branch, the branch name. I'll call it dev. Enter. It's been created. To create another, I'll say branch, git branch, staging. Git branch, features. To list the branches, I'll say git branch. These are the branches: dev, features, master, staging. Let me add it to our list of commands. Git branch, git branch, the branch name, branch name. To switch from one branch to the other, all right? To switch, I'll say git checkout, then the branch name. Let me say dev. It will tell me that I have switched from what branch? I've switched from this branch, the master branch, to what? To the dev branch. So let's check git branch. You always see this green highlights and asterisk, meaning that that is the branch that is currently active. That's the branch that is currently what? Active. Git checkout. Git checkout. Then the branch name. Branch name. Right? So the checkout branch is used to switch from one branch to the other. All right? Now, for instance, I need to delete some branches. Git branch -d, the D flag and the branch name. Let me say features. It will tell me that this branch was deleted. So if I do git branch, I'm left with just 3 branches. That's it. Similarly, git branch -d staging. Git branch to list. I'm left with what? Dev and master. Let's put that down. Git branch -d branch name. All right? To delete a branch. So let's still look. So that was everything about branch. All right? Now, let's talk about branching strategy. Branching strategy are different methods that are employed in the concepts or in the context of Git branching. All right? These methods are methods that are used to control branching conflicts. Branching conflicts. All right? Let's look at Google and see what Google has to say about branching strategy and the types of branching strategy and which one is better. All right? Great. So let's say Git branching strategy. Now, what are Git branching strategies? Git branching strategies are patterns or approaches that teach teams use to organize and manage their code through different branches in a Git system. All right, it's a way of managing and organizing your codes in different branches. Now, they say, well, they have 4 Git branching strategy that you definitely need to know. Underline the word definitely need to know. So let's right click and open this link and see. 1 second, guys. 1 second. Okay. Now, 4 Git branching strategies that you definitely need to know. Let's check. William now. Okay. What are the different branching strategy? Okay, master branch, integration branch, staging branch, dev deploy branch. There's something I need to show us. This is correct, too. This is correct, but there's a naming convention. All right, let me check other sources. Let's check other sources. What are the most popular Git branching strategies? Okay, this is what I need to see. Trunk-based development, feature branching, Git flow. Let's show us this. If you say this, you're not wrong. You're not wrong, but the interviewer is looking to listen to something called something like trunk-based, feature branching, Git flow. I think, yeah. So let's look at what these strategies are and which one is, if you use it, you are at more advantageous. All right. All right. Now let's check. Git branching strategy allows developers to collaborate on a project while also tracking changes and maintaining multiple versions of code base. This guy said it's differently. Approach for managing or organizing. That's saying, I think this is simpler for organizing your code through different branches. I'll advise you go with this guy's definition. All right. The process and approach for organizing your code through different branches. Now, there are different branching strategies. We have a trunk-based strategy, feature branching, and Git flow. Let's see that. In a trunk-based strategy, in which all developers make changes directly on the main branch. Trunk-based, they make changes directly on the main branch, commonly referred to as the trunk. Something similar we have in here, all right? Let's check. Let's go on. Commonly referred to as the trunk, which holds the project's deployable code. Now, in a trunk-based development, in a trunk-based branching strategy, all developers make changes to the main branch, directly to the main branch. Let me put it somewhere here. Branching strategy. This is an approach for managing and or organizing your codes in different branches. Now, the different branching strategies are: 1, trunk trunk-based branching strategy. In this approach, all developers commit their code changes to a common repository known as the main or master branch. I think I've tried to make it simpler. In this approach, all developers commit their code changes to a common repository known as the main or master branch. Let's check it out again. All developers make changes directly on the main branch, commonly referred to as the trunk, which holds the project's developable code. Developers are encouraged to commit frequently and use feature toggles and other techniques to manage changes that are not yet ready for release. Testing is typically automated with a focus on continuous integration, continuous delivery to ensure that code changes are thoroughly tested before they are deployed. So this was what? Trunk base. Now, feature base. Feature toggles, also known as feature flags, can be used in software development to manage features that are not yet ready for release or that need to be shown only to specific users or groups. They function like a switch that can be turned on and off to enable or disable a particular feature in the code base. Now, in the idea of feature branch, let's come there now. Feature branching strategy. In this approach, code changes are deployed to specific feature branches. They call them feature branch. They call them feature. You see in a highly intensive production environment, when you go through your GitHub repository, right, you see things like feature, let's say for instance, feature 01. Okay, I can't do anything because this is not my repository. This is not my repository. This is not my stuff. All right, it's somebody's stuff. Okay, but you can do it somewhere here. You can come down here. Git branch feature. Git branch feature login. Git branch. So these branches, they hold your smaller changes, features. Now I need to add, for instance, now in my web application, if I need to add a color somewhere here, now assuming that this is my web application, I then mean I could open this guy. This is YouTube. This is YouTube. Now, okay, great. I can open that. Oh shit. It's not the proper website. Okay, let me just use it like this. Now, assuming now, in the development of this application, The client said, okay, I don't like the portfolio. I don't like the portfolio line staying below my name. I want my portfolio to be somewhere at the top. Somewhere at the top. Now, the developer is going to create a branch. Git branch feature portfolio. Now, this branch is going to contain the changes that will make this portfolio to move from here to the top. That is the idea behind a feature branch. That's the idea behind what a feature branch. So in this approach, code changes are deployed to specific feature branches, right? Changes. Oh, sorry. Changes are made in bits. Changes are made in bits. Now, the moment the feature has been accepted, the moment the feature has been accepted, the branch could be merged. The branch could be merged to the main branch, the main or master branch, which is your production branch, to the main or master branch. So this is a play around feature branch. The last but not the least is what we call Git flow. Let's check. Git flow. Now, I think I'll share this link with you so that you also read these guys. Okay, it's very key. All right, you look at differences between these guys, their pros and cons. Okay, right? Then Git flow. Git flow is a branching strategy that uses two main long-lived branches, main and develop. Main and develop, that remain in the project during its entire lifetime. Additionally, it employs several short-lived branches like feature, release, hotfix that are created as needed to manage the development process and deleted once they have fulfilled their purpose. The main branch is a stable production-ready code, and the develop branch is where all development takes place. Feature branches are used to develop new features or changes. Release branches are used to prepare for new releases. And hotfix branches are used to quickly address critical issues in a production environment. So this is what you have here. So we are being told that we have two long-lived branches. They call one main and they call the other develop. It could be master, it could be develop. It could be master, it could be what? QA. Now, this process is divided into other branches like the feature branch, the release branch, and the hot fixes branch. So we are told that feature branches are used to develop new features or changes. Take note, guys, new features or changes. Release branches are used to prepare for new release. Hotfixes are used to quickly address critical issues in production. Now, look at the legend. This is a legend. The legend goes with the coloring. We have main with blue, sky blue. sky blue. This is the main branch. The main branch is this straight line. Then if there's anything that we need to fix quickly in production, this is the hotfix. So we're going to create that hotfix. We'll create the hotfix. Then from the hotfix, we are going to merge it. You merge it to what? To the main branch. You also have a develop branch. So the develop branch runs parallel to what? The main branch. Develop branch is this Ribena color. This develop branch. So in either way, if you need to do a hotfix to develop branch, you can also do the hotfix develop branch. Now you also have feature branch. Feature branch, you can make your changes on the feature branch and you do a merge. Do a merge toward develop branch. The same feature can be merged toward the main branch. This same feature could be merged towards the main branch. This is the whole flow about Git flow branching strategy. All right. So I'll share this guys with you guys. So you take your time and you look over it. Take your time, you look over it. 1 second, guys. Okay, so that was branching strategy. All right. Now let's talk about Git merge and Git pull and push. Now, look at this now. Git branch. All right. Git status. My dev branch is empty. All right. Dev branch is empty. CO. Let me switch back to master. Git checkout. Master. Git branch. Master. So I have these files on master. Let me switch to one of these feature branches. Git checkout. Feature. Feature login. I'll switch to feature branch. Now feature branch. Now Git branch. I'll switch to what? Feature login. So on this branch, I want to create a file. I'll say touch login.php. Touch app.php. Touch mkdir source. Git status. Now, I want to add these guys from the on track area to the tracking area. So as you see before, I've been doing git add, then the file name. One by one, right? But what if I need to add all of these files at the same time? How do we do it? Let's do it. So git add space dot. Git add space dot. So that dot is going to add everything from the on track area into what? The tracking area. So let's check git status. You can see everything has been added. So if I need to restore them back, I'll say what? Git restore dash staged dot everything. Let's check git status. Instead of me to be doing one by one, I'm doing all. Let's add them back. Git add all. Git status. Now let's commit. Git commit -m. Make sure you always commit your changes. Commit added some files. Enter. Oh, sorry. 2 files were added. Two files were added. One sec, guys. Yes, ma'am. I'll finish your call. Okay, so if we do git status to tell us that the branch is clean. Now let's check. Why is this directory not adding? Directory is not adding. Okay. We've seen app.php. Now I want to switch branch. CO git checkout master. Now let's check those files. You see that I no longer have those files because those files were not created in the master branch. They were created in a different branch. App.php, login.php. They were created in what? In the feature branch, feature login branch. Let me switch to dev branch. Now, while I am on dev branch, I want to merge git branches. Git branch. I want to merge login to dev so that the content of login will be seen in what? The dev branch. As you can see, there's nothing in the dev branch. Dev branch is empty. So while I am on dev branch, I'm going to merge the feature login branch to dev branch. So this is what I'll do. I'll say what? Git merge. Git merge feature login. Enter. So updating this guy. Fast forward. App.php, login.php. 2 files were changed. Now let's check my branch again. Git branch. I'm on what? Dev branch. If I check ls now, I should see those files. Before, those files were not there. Now, those files are now coming because of I've merged them from what? The feature branch towards the dev branch. Remember, you need to be on the branch that you want to merge another branch with, which I did. I was on the dev branch. Since I needed to merge a feature branch to the dev branch, I have to be on the dev branch. So if I need to merge the dev branch to the master branch, I'll have to be on the master branch. Now let's change branch. Git checkout master. Now if I do ll now, you see that those files are not here. These files, app.php, login.php, git branch. I'm on what? Master. Now I need to merge from dev to master. So I have to be on what? Master. So I'll say what? Git merge dev. I have merged these files into master. If I check this guy, I should have those files now coming. So this is how you play around with merging. All right, great. Now, all of these things we have typed so far, all these commands you've seen that you've typed, git merge. All right. These operations can be performed on the GUI, on your GitHub. On this GitHub, you can perform everything that we have done on the CLI. Everything that we have done like this, we can do it on this CLI. All right. But it's always better, recommended, you understand how to use Git CLI to create local repository. All right. Now, I want to do something. Git branch. I'm on the master branch. I want to create a file. I want to create, PHP. I want to create a content into this file. This was created by the master. Control D. It will Control D. What is this? I see. Oh, I see. Control D. What the fuck? Wait, guys. Wait. Hey, someone messed me up. Control D. Wait to Control save. No. I call mo. No. Shit, man. Option. Hey, I don't enter. So I need to exit this guy. I've divided this screen. I've not used this one before. I need to exit. I don't place this now. Oh, it's Timox that does this. Timox that does this thing. Guy. So I have to close. Let me close this thing. Let me close it. Oh, rubbish is that. Let me come back in again. Copy. Change to works. All right. What was I doing? Git branch. Okay, I was editing that content. App.php. I've edited this file. Now, see you. I will switch branch. Git checkout. Dev. I have switched branch. I need to modify this file. PHP. See you. This was created by master. This was added by who? By dev. Escape. Save and quit. Git status. Remember, I did not add the file. The file is modified, so I need to add it. Git add everything. Git commit. Commit message. added some content. All right. This is Git branch. This is dev branch. Now I will switch back to master branch. Git status. Everything is clean. Now I need to merge. I need to merge dev again. So here's what I will do. I'm on master branch. I say git merge dev. Okay. What I want to do now, I want to cause a conflict. I want to cause a conflict. That's what I want to do. But the conflict is not happening. Now, let me modify this file, app.php. Let me remove this line. Another content added by master. Save. Git status. I'm going to add it now. Git add. Git commit -m. Master added content. Now I will switch branch. So git branch is this master. Git checkout dev. Open the file vim app.php. This is, you can see we can't see the content of that master that he added, but master added some content and committed, but the changes is not reflecting. The changes that master made is not reflecting on dev, right? It's not reflecting on dev. So for those changes to reflect on dev, master is supposed to merge to dev. But now I want to cause conflict before I will show us that aspect. This was added by dev. Added by dev. Save. Git status. Git add. Git commit. Dev added. Git, oh sorry. Git commit.
The spelling of command.
Yeah.
Commit.
Thank you. Thank you. Now, added, right? Let's try to merge. I'm going to merge the content of master into here now because I am on dev. So I'll merge master to dev. So I'll say git merge master. Perfect. Auto merging this guy. Conflict, content, merge conflict in app.php. It's now pointing the file that has a merge conflict. Automatic merging failed. Fix conflicts and then commit the result. Now, I want to see those changes. So I'll say git difference, git div app.php. Take note, guys. Take note, guys. This guy is complaining. He's complaining bitterly that there's a conflict in the content of this file, the content in this file. So I don't know yet. So I want to see the difference. He said, let me use --cc. Let me try it. --cc. Let me see what that guy will do. Nothing. Now see. What did you do? Nothing. Now, see you. When you see plus, plus means something was added. Minus means something was removed. All right. So I have tried to merge, but merge is failing. So I need to go into this file and edit this file. So I'll go into app.php. Once I open this file, I will see the lines that does not need to be in this file. So you can see this line, which is let me set line number. Line 4, line 7, line 9, line 10, okay, line 9, line 12. So all I need to do, I'll just delete those lines. Delete. Line 6, delete. Line 7, delete. Line 9, delete. Now I will save and quit. I'm on where? I am on dev. I need to merge again. Now, git merge master to this guy. Enter. This is an error. Merging is not possible because you have I've not added, I've made changes. Git status. I've modified the file, I need to add it. So git add, git commit -m made changes. Sorry. Now, git merge master. It has been merged. So I've merged master to dev. Now let's check that file again. Check the content of that file. Vim app.php. So the content from master has been added, which was this part. Has been added to this file. So this is the behavior of git merging, and when you run into conflict, git conflict. All right, great guys. So far so good. We have seen almost basic, I won't say basic, but common git commands that you could use on your day-to-day basis, on your day-to-day activity. Very common git commands. I'm not sure if it's just me, but I don't have sound anymore. Can anybody hear me, please?
Yes.
Yeah, man. So Paul, go out and come back in again. So these are common git commands that you're going to see and you're going to be using on a daily basis. All right. So we've not talked about git push and git pull. These two commands are related to managing remote repository. So when we come tomorrow, we shall kick off with creating a GitHub account, create repositories. All right. Then see how we can manage a GitHub repository from the command line. Then we shall talk about remote repository. So we shall also talk about a new command, git remote add origin. Let's check that out. Git. So talk about we saw git div, we saw git log, we saw git status, git branch, git commit, git merge. Okay, this is just a tagging, git switch, resets. So these are for collaboration. Git pull, we're going to see git pull and git push tomorrow. Then let me go to the top. We saw git add. You can always remove a file, from working tree and from the index. Okay. So why is not showing those management commands? Git add, sorry, it's like this. Git add is not git remote, it's git add remote, I think remote origin. Let me check. So git add dash help. So git add, can we, anyway, when we meet tomorrow, we shall look at it. All right. Remote add origin or git add remote origin, whatever. So at this juncture, guys, is there any question? Is there any query? All right, so I won't trash this server. I want to save it. So sudo power off. So since there's no question, I want to thank you and apologize for that delay at the beginning. And thank you. And I would love to see you guys tomorrow, 7 p.m. All right. Too much to be too much. Right. So
Thank you so much.
yeah, man.